All right, so multiplication and addition of fractions. Just to make sure that we are comfortable with the difference between multiplication and addition and fractions, I want to take a look at these. If we're going to multiply 1/2 times 2/3, or excuse me, 1/2 times 1/3, what we're going to do there, multiplication of fractions is really simple. All we're going to do is we are going to multiply the numerators together and get 1, multiply the denominators together and get 6, and that's it. Multiplication of fractions is as simple as multiply the numerators, multiply the denominators. You might reduce the fraction after you're done, but here we don't need to. Our answer is just 1/6, and that's all there is to it. Adding fractions is a little more involved. A lot of times we think addition is going to be the easiest of the operations, but that's not true with fractions. If we wanted to add 1/2 plus 1/3, we can't do that the way this fraction looks. The first thing we've got to do is get a common denominator. What do we want to use for a common denominator for 2 and 3? Since I have to have a common denominator, thanks, Austin, that'll be 6. So I'm going to rewrite both of these fractions so that they have 6 as a denominator. Thanks, Katrina. And we did this last week, creating equivalent fractions. If I multiply the denominator by 3 to create an equivalent fraction, I have to multiply the numerator by 3. And what we're saying there is that 3/6 has the same value as 1/2. And then similarly over here, if I want to multiply the denominator by 2, I multiply the numerator by 2, and we're saying that 2/6 is an equivalent fraction to 1/3. Now that I have common denominators, really I'm looking at adding 3/6 plus 2/6. And the way that we'll add those is, if you think about this for a minute, if I have 3/6 of something, and I have 2 more sixths of something, and I put it together, I end up with 5/6 of something. And that's exactly what happens here. We're going to add those numerators together and have 5. The denominator just stays the same. That's just telling me what my denominations are, if you want to think of it in those terms. And so once we get common denominators, we'll just add the numerators, the denominator stays the same, and we end up with 5/6. Related to addition is subtraction. If we wanted to do 1/2 minus 1/3, we can't do that until they have a common denominator. So the first thing we'll do is get a common denominator, and that'll be 6. If we multiply the denominator by 3, we multiply the numerator by 3. So 1/2 we rewrite as 3/6. It's an equivalent fraction, and it's a convenient form for me for this particular problem. 1/3 becomes 2/6, and then we subtract. And just like was the case with addition, the denominator is just going to stay the same. If I have 3/6 of something and I take 2/6 away, I'm left with 1/6, and that's exactly what happens here. We'll go ahead and subtract those numerators, 3 minus 2, and end up with 1/6 as our answer. The biggest difference here between multiplication and addition of fractions is when we add and when we subtract, we have to have a common denominator before we can do the operation. Multiplication, we just multiply them, and that's all there is to it. Let me know if you have any questions on any of that. Okay, great. Mixed numbers, and we looked at mixed numbers a little bit with some of our problem solving last week, but I want to go into it a little more deeply right now. If we have the number 3 and 1/4, what we have there is this number has a whole number part, and it has a fraction part. That's what makes this a mixed number, is because of the pieces that it's made up of, a whole number part and a fraction part. And we could break this down and write it a little more explicitly. And this is just sort of a path along the way here, where 3 and 1/4, well, that could be 3 plus 1/4. That's exactly what 3 and 1/4 means, is 3 plus 1/4. We just write it as a mixed number. If we wanted to expand that out further, it could be 1 plus 1 plus 1 plus 1/4. Let me know if anything doesn't make sense. You might not see the y yet. That's okay. Just that 3, I turned into 1 plus 1 plus 1. And now I'm going to rewrite those ones so that they have a common denominator with my fraction. So instead of 1, I'm going to write that as 4/4. I'm rewriting 1 as an equivalent fraction that has 4 as a denominator because of my 4 that's over here in the denominator. Okay, so that's plus 4/4, and that's plus 4/4, and plus 1/4. And so what the actual value of this number is, this mixed number 3 1/4 that I started with a long time ago, now I can add those fractions because they all have a common denominator. So I can add the numerators, and that's 4, 8, 12, 13. So what we just did here, in sort of a long way around, was we found that 3 1/4 has the same value as 13/4. Now, 13/4, when we have a bigger number in the numerator than we do in the denominator, that's called an improper fraction. I'm going to put improper in quotes because there's really nothing wrong with it. What you'll find is in a lot of situations, having an improper fraction can be pretty valuable and useful. So it's not that it's wrong, it's just the name of it is improper because the numerator is bigger than the denominator. That's all. And what we're saying here is that these two things have the exact same value, 3 1/4 and 13/4. Does anybody know of a shortcut that can take you from 3 1/4 to the improper fraction that has the same value without having to go through all of this? And it might not be that easy to type, so I'll definitely be forgiving with you as you do that. Multiply 3 and add 1. Good, Katrina, that's excellent. Multiply 3 and 4 and add 1. Very good, Kate. Multiply the whole number by the denominator and add the numerator. Excellent, Laura. Very formal. That one's very formal. All of those are good. And I know exactly what all of you mean. And there is a shortcut that we can use here if we want to take a mixed number and turn it into an improper fraction. What we do is, and this is what all three of you said, we're going to take this 4 down here and multiply it by 3. That gives us 12. And then we add that 1 on the top. So it's 4 times 3 is 12 plus 1 is 13. And the denominator stays 4. And that's exactly what you've all said there. And that's our shortcut. We'll do 4 times 3, add the 1, and get 13/4. That's how we turn a mixed number into an improper fraction. Are there any questions about that before I have you try one? Okay, great. Here goes. I'll set up a poll for this one. Convert 5 2/3 to an improper fraction. It may take me longer to type this up than it will for you to come up with an answer. That's okay. So which one of those is 5 2/3 written as an improper fraction? We'll go another 20 seconds and then talk about this one. All right, let's see how we did here. Okay, unanimous. Perfect. Very good. All right, we're really comfortable with improper fraction. That's great. So our shortcut here is to say, all right, well, I have this mixed number that is 5 2/3, And to turn this into an improper fraction, I'm going to multiply 3 times 5, that's 15 plus 2, that's 17 thirds. That improper fraction has the same value as 5 and 2/3. We haven't discussed this, but historically this has gone well. I'm going to see how it goes with you. We're going to go the other direction. 23/7 is an improper fraction. I want you to turn that into a mixed number. I'll make a poll for this and let you try it. So which one of those would be the mixed number version of 23/7? What we're doing here is we're coming up with a whole number part, and then whatever's left is the fractional part that goes with it. This has some links to working in base 7 almost. Not exactly the same, but there are some similarities in here to working in different base. We'll go another 20 seconds and then we'll talk about this one. Okay, let's see how we did here. All right, unanimous again. Very good. Okay, great. I feel really comfortable about where we are with converting back and forth, but let's go ahead and take a look at the process here. We're going to say, all right, well, I have 23/7. The first thing I need to know is how many times will 7 go into 23? So we'll go ahead and do 23 divided by 7, and we'll get 3. And then we need to kind of figure out, well, how much of this did we account for? If I do 7 times 3, that's 21. So I still have 2 left to go. And 3 2/7 is what we've got. A nice way to check this is to just go the other direction. 7 times 3 is 21 plus 2. That's 23 over 7. So I know I'm correct. And so 3 2/7 is what we end up with here. 3 being our whole number part, 2/7 being our fraction part. Now we're going to add mixed numbers. So we're going to take the degree of difficulty up a little bit here, and we're going to say, all right, we want to add 2 3/4 to 1 5/7. There are 2 different ways you can go about this. We're going to look at both. You can do whichever one you like best. There's not really a right or wrong here. I kind of have a preference, but that's me personally. You will probably have a preference also. The way I'm going to go about adding this is I'm going to start by just adding the whole number parts together. 2 plus 1 is going to give me 3. Okay, now let's go look at the fraction part over there. I have 3/4 and 5/7. In order to add those, I need a common denominator. What's that common denominator going to be for 4 and 7? Careful, Katrina. Make sure you're looking at the denominators, that 4 and that 7. So yeah, Laura, we'll use 28 there as our common denominator. So I'm going to rewrite those fractions with 28 as a common denominator. If we multiply the denominator by 7, we multiply the numerator by 7. If we multiply the denominator by 4, we multiply the numerator by 4. Let me know if anything, no problem, Katrina, I totally get it. Just let me know if anything there didn't make sense. Now I can add those fractional parts together because they have a common denominator. When I do that, 21 plus 20 is 41. The denominator is 28. Well, that's an improper fraction. I'm not going to leave my mixed number as 3 and 41/28. Instead, 41/28, let's see, that would be 28/28, oops, plus 13 more 28s. And you don't have to write all this down if you see it right away. I just want to be really explicit so you can see what's happening here. That 41/28, well, let's see, that becomes 1 and 13/28. And I need to add that. I need to add my 1 and 13/28 to this 3 that I have over there to end up with 3 and 1 is 4 and 13/28. And there's the solution to my problem of adding those mixed numbers together. I don't think any one step in there is complicated, but there is kind of a lot to keep track of. So you want to be patient and you want to be careful as you go through this. The way I did it was I added the whole numbers together to get this 3. I want to add these fractions, but in order to do that, I have to have a common denominator. Okay, well, I'm going to create equivalent fractions that have the common denominator that I'm looking for, and then add those. And now I got 41/28. Well, that's an improper fraction. I'm not going to have an improper fraction as a part of my mixed number. So now I need to turn that into a mixed number, which is something we did just a minute ago. And now I have to remember, okay, this 1 and 13/28 needs combined with the 3 that I had from before to give me a final result of 4 and 13/28. Let me know if you have any questions about anything there before we do this again using a different approach. All right. We want to add 2 and 3/4 plus 1 and 5/7. The way we did it a minute ago was we added the whole number part, then we added the fraction parts, and we put those together to our answer. Another approach you can take here is convert these both to improper fractions right out of the gate. And we'll say 4 times 2 is 8 plus 3, that's 11/4. Our other number, 7 times 1 is 7 plus 5, that's 12/7. Now I need a common denominator so that I can add those. That's still going to be 28. And now I need to create equivalent fractions. I'll multiply the denominator by 7. If there's a downside to this, it's that your numbers can get a little large, and that can make things kind of clumsy because we've got to do 11 times 7 and call that 77/28. It can be easy to get lost in the big numbers, but there's nothing wrong with this approach. 7 times 4 is 28. 12 times 4 is 48. Now I have a common denominator, so I can add those. And when I add those, let's see, 77 plus 48 is 125/28. And now I just need to turn that into a mixed number. So we'll divide 125 divided by 28. I get 4 point something. So it's going to be 4 and then some kind of a mixed number after that. So far, I've taken care of 28 times 4, which is 112. And so when I do 125 minus 112, that leaves me with 13/28. I better get the same answer I got the other way because they both work. And either way, I got 4 and 13/28. Either approach is completely fine. Let me know if you have any questions about those. Okay, very good. Here goes. You try one. 4 and 3/8 plus 2 and 2/3. I'll set up a poll for this. I see I have a typo in my second one there. That should be 6 and 5/8. Sorry about that. If you get an answer that's not shown, pick the one that's closest to yours, and then we'll know to ask questions when the time comes. Yeah, and that second one there is not 6 over 58, it's 6 5/8. I just have the slash in the wrong spot. We're doing really well with mixed numbers so far. I'm anticipating the same thing is going to be true here. But if you have questions, don't hesitate to ask them. We'll go another 30 seconds and then do it together. Okay, let's see about this one. Unanimous again. Wow, we're having a fantastic day. That's terrific. All right, so we'll dive into this one just to talk through it. Let me know if you see something that doesn't make sense. We have 4 3/8 plus 2 2/3. I'm going to work with the whole number and the fraction parts on this one. If you want to see it the other way, you just let me know and I'll do it the other way. But 4 and 2 will give me 6, and then I want to add 3/8 and 2/3. And so I'll need a common denominator. 8 and 3, I'll use 24. And let's see, multiply by 3, so that's a 9. Multiply by 8, so that's 16. If you see anything that you're not sure of where it came from, you let me know. Then I'll add those. Adding those fractions, I'll have a denominator of 24. 9 and 16 is 25. So that's 1 and 1/24. And then putting it all together, I have this 6 and this 1 to make 7 and 1/24. And that's how we'll add those mixed numbers. Let me know if you have any questions about that. So far, we're just doing great with all of the mixed number and proper fraction stuff, so I'm thrilled. Okay. Subtraction of mixed numbers. A little bit more difficult than addition of mixed numbers, so we'll be patient with this. We've got 5 3/5, and we want to subtract 2 6/7. Okay. So let's see here. I think I'm going to, in this one, I'm not going to charge forward and do 5 minus 2 is 3 to start with. I'm going to hold off on that and start with the fractions first. And so I need a common denominator to be able to subtract those. So that'll be, let's see, 5 and 7, that'll be 35. Multiply by 7, multiply by 5. And now I want to subtract 21 minus 30. I can't do that. I can't do 21 minus 30. So I'm going to have to borrow. And here again, this leans back into our working in other bases a little bit, because I'm going to borrow from this 5. And I'm borrowing 1, which what I'm actually borrowing in this case is 35 35ths. That's how I'm borrowing 1. So essentially what I'm saying here is, well, let me go ahead and add those together. So now that I've borrowed, what I have on top is 56 35ths. And what I'm saying in kind of a strange roundabout way, let me know if you want to ask anything about it, is that 5 3/5 that I started with, what I've done here is I've rewritten that as 4 and 56 35ths. That has the same value as what I started with, but it has 35 as a denominator because I need that, and I have a number big enough that's going to allow me to subtract now. So as far as the fractions go, I still have this 30. I'm going to subtract 56 35ths minus 30 35ths. When I subtract those, let's see, that's what, 26 35ths? I'll subtract my whole numbers now, which is 4 minus 2, or 2, and I end up with 2 and 26 35ths. That's a little more challenging than doing the addition, because here I had to borrow, and what I had to borrow was 35 35ths to be able to subtract. 26 35ths sure looks like it would reduce, but I don't think it does. So I guess we're all done there. Let me know if you have any questions on that before I have you try one that's similar. I do think this can be a little complex, so please don't be shy if you want to ask anything. Okay, very good. Here goes. 7 1/4 minus 4 2/3. I'll make a poll for this one. Okay. I was a little more careful with my typing there. I think they're all what I wanted to be. If you get an answer that's not there, pick the one that's closest to yours, and then make sure you ask about it when that time comes. A little bit harder than addition, but I think you'll be all right, given the way everything's gone so far. We'll go another, let's say, 25 seconds and then do it together. If you need more time, let me know. Get an answer that's not there. Pick the one closest to yours and make sure you ask questions. Okay, let's see how we did on this one. Not unanimous, but close. A couple of disagreements. Okay, so this is the most complicated thing we've done. So let's be patient and talk through it. We're doing 7 1/4 minus 4 2/3. I want to subtract those. And because it's subtraction, I'm going to start with the fractions instead of the whole numbers. And let's see, 1/4 and 2/3. I want to get a common denominator for 4 and 3, so I'll use 12. Multiply denominator by 3, multiply numerator by 3. We're saying 3/12 is an equivalent fraction to 1/4, but in this particular case, I want it with a denominator of 12. Multiply by 4, we're saying 8/12 is the same as 2/3, but in this case, I want a denominator of 12. I'd love to subtract, but I can't do 3 minus 8. So I'm going to have to borrow. And when I borrow 1 from this 7, making it a 6, what I'm borrowing is 12/12. I'm borrowing 1, which is 12/12. Now I can combine those together in my numerator and have, let's see, that's 15/12. Now I have a number big enough to subtract. In the big picture, Just a reminder of what I'm saying here is that 7 1/4 has the same value as 6 15/12. Those have the same value as each other, but for this particular situation, writing it as 6 15/12 is extremely convenient for me. So I'm going to write it that way just for this particular situation. Now I can subtract this 15/12 minus 8/12, and that's 7/12. Now we'll do the whole number. 6 minus 4 is 2, and we wind up with 2 7/12 as our answer. If there's anything in there that didn't make sense, let me know. If you made a mistake and you see where it was, that's fantastic. That's exactly why we talked through them. Okay, does anybody have any questions about what we've done with mixed numbers, improper fractions, adding and subtracting fractions, adding and subtracting mixed numbers? All right, Will, very good. Okay. Let's talk least common multiple. This is very much related to greatest common factor. And the reason that it's very much related to greatest common factor is because we're going to use prime factorization again. If we want to find the least common multiple of two numbers, and what that is it's not, with greatest common factor, it was what's the biggest number that will divide evenly into these numbers. Now what we're looking for is the least common multiple, the smallest number that 45 will go into, that 60 will also go into. It can be handy for finding a lowest common denominator, but I don't know, lowest common denominator is a little bit overrated. Any common denominator will do. Anyway, for least common multiple, the first thing we're going to do is we're going to find the prime factorization of each number. So here's 45, and like we saw last week, you may do it differently, and that's okay. I see 3 times 15, and that's 3 times 5. And so I have 3 times 3 times 5, so I'll write that as 3 squared times 5. If you see anything in those prime factorizations that doesn't make sense when we do it, make sure to ask. In looking at the show your work from last week's quizzes, this was the easiest thing for me to spot. Okay, now we need the prime factorization of 60, and that's 6 times 10, which is 2 times 3 and 2 times 5. Putting it all together, it looks like I have 2 squared times 3 times 5. So I have my prime factorizations. Now what I want to do is find the least common multiple. Just as a reminder, last week when we were doing greatest common factor, what we did was we looked for what they had in common and we kept that. Now we're not going to do that anymore. We're going to keep the highest power of everything we see. So there's no 2's over here, but there is a 2 squared over here. I'm keeping 2 squared. I'm keeping the highest power of everything that happens. I have 3 squared. I have 3 to the first. I'm keeping the highest power, so I'm keeping 3 squared. There's a 5 to the first and a 5 to the first, so I'll keep 5 to the first. I don't make it 5 to the second. I just keep whatever I see. I keep the highest power of whatever I see anywhere. So we're not looking for the overlap here. In some ways, we're doing union instead of intersection. I'm keeping the highest power of everything I see. And now I'll multiply those together. And let's see, that's 4 times 9 times 5. Let's see, 4 times 9 times 5 is 180. And that's the least common multiple of 45 and 60. It's the smallest number that both of those will go into evenly. If you wanted the least common denominator for fractions that had 45 and 60 in them, you could use 180. That would be the smallest number they'd both go into. Let me know if you have any questions about this before I have you try one. The key here is the difference between this and greatest common factor is in that green box. Here we want to keep the highest power of everything we see. Okay, here goes. Find the least common multiple of 30 and 44. I'll set up a poll for this one so you can try it. For these, you'll start with prime factorization, and then you just have to make sure the right decisions are made to get your number, whether greatest common factor, which is a little different from least common multiple. It's part of the reason I put them in different weeks is I like getting real comfortable with one before we do the other. Prime factorization, you might do it different than somebody else. That's okay. You're going to end up at the same place. Go another 25 seconds, and then we'll do it together. If you need more time, let me know. We can go 30 seconds for sure. And if you get one that's not on the list, pick the one that's closest to yours. All right, let's see how this one went. Unanimous again. All right, that's excellent. It's really easy to make a mistake with this one in looking for what it is that you should keep and what it is that you don't need to keep. So I'm thrilled to see this one go so well. So we need our prime factorizations. We'll start with 30. I'll do 3 times 10 and 2 times 5. And so our prime factorization there is 2 times 3 times 5. That's how we'll get 30 as a product of prime numbers. And then for 44, 4 times 11, and then 2 times 2. So it looks like 2 squared times 11. It's kind of a weird one, but I guess that's how it goes. And now what we want to do is keep the highest power of every term we see. I have 2 and I have 2 squared, so I'll keep 2 squared. I have a 3. I don't have a 3 in the other one, but that's okay. I'm keeping the highest power of everything I see. I have a 5 over here, so I'll keep that. I have an 11 over here, so I'll keep that. And I'll multiply all this together, and that's 4 times 3 times 5 times 11. And that's 660. And so the least common multiple of 30 and 44, the smallest number that they'll both go into evenly is 660. Poll went great, but let me know if you have any questions. Okay, a little bit of problem solving today. A bag of fertilizer seed blend is made up of 1/9 nitrogen and 2/5 grass seed. The rest is soil. What fraction of the bag is soil? There's a couple of different ways you can go about this. You could start with one whole bag of soil and subtract off of there. Nothing wrong with that. I think the first thing I see is how much of it is not soil. And that's, well, 1/9 of the bag is nitrogen and 2/5 is grass seed. So if I add those together, that's how much of the bag is not soil. So I need to take 1/9 and add it to 2/5. Have to have a common denominator. What's a good common denominator for 9 and 5? All right, good, Katrina, Laura, 45. So we'll use 45 as our common denominator here. And let's see. multiply the bottom by 5, so multiply the top by 5, multiply the bottom by 9, so multiply the top by 9, and I can add that, 5 and 18, that's 23/45 of this bag is not soil. So I have the entire bag, which would be one whole bag minus the 23/45 that's not soil. Or I could, and you might not have gone with one at the beginning, but one whole bag, everything that's in there is 45/45 of what's in the bag, and we'll subtract 23/45. Ugly numbers in this one, but that's all right, we can handle it. 45 minus 23, that means 22/45 of this bag is soil. Everything else. If I find out that 23/45 is not soil, then everything else, what I get when I subtract, that must be how much of the bag is soil. Darn near half, but not exactly. Do you have any questions on that one? The key here is just basically taking those skills we've learned with fractions and mixed numbers and applying it into a real world kind of setting. Okay, very good. Last thing I need to say today is number 5 in the homework instruction to do it mentally. You don't have to do it mentally